And then what I'd like to leave as open problems is whether or not there's any simple deterministic n log n algorithm. That's still, I mean, a classic open problem that still remains. And I think more interesting, at least for the context of privacy-preserving computations, is what are some other oblivious problems that other oblivious algorithms we could construct for various existing problems that are out there. You know, proximity searching, graph connectivity, minimum spanning trees, shortest paths, these kinds of algorithms. Can we come up with optimal, oblivious, maybe even randomized algorithms for these problems?
You'd have to change the building block. The primitive.
Yeah, so what I want is the primitive is some sort of a circuit, constant number of inputs, constant number of outputs, polylog n time to execute that little circuit.
So Bellman Ford would be a nice place to look, right? Or could the semi-ring up.
Yeah, then they has to just test the changes, what is the primitive. So anything that can be, because this randomized algorithm, the SMC protocols just need a circuit. So anything you can simulate with a little black box circuit will work as your black box, and then just fit that into your oblivious algorithm, and you've got now privacy preserving computations. So for instance, there's a lot of heat going on right now in location-based services for small cell phone-like devices. You can find out who are my friends in town, who can I go party with. There it is on your and but there's a lot of privacy concerns about that. If suddenly everybody knows where you're at, maybe sometimes you don't want people to know where you're at. And so you'd like to be able to do that query, tell me who are my friends who are nearby, without revealing where I'm at to non-friends. This kind of queries would be great. But I think they're going to, in order to do this efficiently, I think we need oblivious algorithms for some of these graph problems in order to do that. So that's, I think, the whole direction of research that has not even been started yet. I think it would be very intriguing to do. So, thank you for your time.
So when going from Monte Carlo to Las Vegas, so now you have a sorting algorithm, but now you lose the data obliviousness. Do we know that that has to be the case, or is it just that we don't know how to do that?
Yeah, in this context, it's not exactly a proof of a lower bound. But at a meta level, that's the only way to convert a Monte Carlo algorithm to a Las Vegas algorithm, is to add a verification step. And by necessity, the verification step has to be data dependent to test if it worked.
I'm going to show none of that came up on the mic.